We're taking a look at problem number 1. So for problem number 1, we want to select all the expressions that are equivalent to 16x minus 12 minus the 24x plus the 4. So we have to identify the stuff that's equivalent first. So when we're taking a look here, I have like terms with my 16x and a minus 24x. Remember, those subtraction signs go with the number that it's in front of, or with the term that's in front of. So we're technically focusing on doing 16x minus 24x. When we do 16x minus 24x, it's going to come out to a negative 8x. Okay, then we've got our constants. Our constants are also considered like terms, so we have a negative 12 and a positive 4. So for a negative 12 plus 4, that's going to come out to a negative 8. So we wind up getting the expression negative 8x minus 8. So we want to identify which one of these are similar or equivalent to negative 8x minus 8. Well, automatically I see one right here, negative 8x minus 8. That's an equivalent form, which means this, B, is not an equivalent form because that's 40x minus 16, and I can't simplify that any further. So I'm going to go ahead and cross this one off. For A and C, they're not in simplest forms, so I need to see if I can actually simplify them first before I can identify whether they are like terms or not. When we're taking a look at problem A, we do have distributive property that has to happen first. What value am I distributing? Amy? Negative 12. So I'm very happy she was able to get that part. The negative 12. You must include that negative sign with it when you are distributing. So you're going to multiply it to the 1. You're going to multiply it to the 2x. So we're doing negative 12 times 1. We're also doing negative 12 times 2x. Okay, when we multiply negative 12 times 1, that comes out to a negative 12. When we multiply negative 12 times 2x, that comes out to a negative 24x. Then everything else is just going to come straight down from the problem. We're still going to have this 4 plus the 16x that's written in front of the minus 12 minus 24x. Right? So then from there, we can identify our like terms. So I'm going to focus on my variable like terms first. So I have a positive 16x and I have a negative 24x that I can combine together. So 16x minus 24x, that's going to come out to negative 8x. Then we also have a positive 4 and a negative 12. So when I use a positive 4 minus the 12, that's going to come out to negative 8. So we get negative 8x minus 8. That is an equivalent form. So answer choice A is also an equivalent expression. Okay, if we take a look at C, problem C, they already have the like terms written side by side here. 16x minus 24x is going to come out to negative 8x. But then we've got a negative 4 and a positive 12. That comes out to a positive 8, which is not the same thing as minus 8. So that's not going to be an equivalent form. So only A and D would be considered our equivalent forms. Hayden, you had your hand raised before? No? You changed your mind? Okay. All right, let's take a look at problem number 2. We're selecting all the statements that are true for any value of x. So no matter what the value of x is, we want to know which ones of these are actually going to be considered to be true statements. So if we're taking a look here, we have 7x plus 3 minus 2x plus 7. We want to know if that is going to be the same thing as 5x minus 4. So if I were to take a look at it, this says that I'm going to do 7x minus the 2x because that negative is going to get distributed to both these components. And then we're going to be doing a positive 3 minus a 7. So 7x minus the 2x, when we do this portion right here, that does give us 5x. When we do a positive 3 minus the 7, that does give us a negative 4. So this is a true statement. A is going to be a true statement. Both sides are equivalent to each other. When we're taking a look at B, 7x plus 5 times the quantity of 2x minus 1. When I distribute This 5 times 2x, this becomes a positive 10x. And then 5 times negative 1, that becomes a negative 5. And we still have that 7x up in the front. Then when we combine like terms, when we combine 7x plus 10x, we do get 17x. And then negative 5 has nothing to combine with, so it stays a minus 5. So that is also a true statement. Okay, for here, when we go ahead and combine our like terms, the only value that's getting distributed is a positive 1, which means nothing's actually going to change in that sense. So I'm going to show you this over here so you can see it a little bit easier. So this is going to just simply be half of an x plus 3 minus half of an x. Well, if I do half of an x minus half of an x, what do I get? 0, 0. So do I need to write 0? No. They cross each other off because they're 0 pairs. So what are we left with? We're left with a positive 3, which is what they have on this side. This is a true statement. Okay, for here, when we have 5x minus 3/4 times 16 minus 12x, we want to know if that's going to come out to the same thing as 12x plus 9. It's not. Okay, when we distribute that negative 3/4 to the 16 and to the negative 12, that's going to come out to a negative 12. And then negative 3/4 times negative 12x, that's going to come out to a positive 9x. And then, of course, we have the 5x that's still in front. Then when we combine our like terms, we've got 5x plus 9x, which is going to come out to 14x, not the same thing as 12x. And then, of course, we have a minus 12 here. That's going to stay a minus 12. So this is not a true statement. Okay, and then I'm not going to take time. I would really like for us to be able to move on. E and F were also true statements. Those all came out to being true. Okay, let's move on to problem number 3. Problem number 3, we're trying to find area. How do we find area? If we're given 2 dimensions, what do we do to find area, Jeremy? You do length times width, right? We are taking the 6 and multiplying it with the 1/2 x minus 7. So that means that we're going to have 6 times a quantity of 1/2 x minus 7. We are creating a distributive property problem here. Okay, you are taking the 6 and multiplying it by this entire quantity. That entire quantity needs to be in its parentheses. So you're going to actually distribute to each of these components first. So we're going to do 6 times half of an x, which is going to come out to 3x. Then we're going to do 6 times that negative 7, and that's going to come out to a negative 42. So there is our area. That's going to represent our area. Okay, are there any questions about that? Okay, let's flip it on over to the next page. What we are doing here, we are focusing on translating expressions. So given contextual problems, contextual word statements, we're going to go ahead and translate. So here are some of our translation words. Okay, we already had that list from our previous unit, but some translation words for addition, translation words for subtraction, multiplication, and division. So I'm going to go ahead and just so when we're going through our contextual problems, anytime I see an addition word, I'm going to highlight those addition words in pink. Or sorry, not pink, green. I'm so sorry. Scratch that. It's going to be green. My subtraction words I'm going to highlight in my pink. Any of my multiplication words that I see I'm going to highlight in blue. And anything that is a division problem, I'm just going to highlight it in orange. Makes it easier for me to be able to identify those words. Okay, that's the second time I'm saying to stop. Where are your notes, Daniel? Then you should take out a piece of paper and be writing, right? There's scratch paper right there. Okay, so when we're looking here, 6 more than x, if we're taking a look at our terms, when we see the terms more than, let me first go through some of these words. Obviously we know sum, we know together, we know plus, we know add or added to, increase, and more than. One of the things I want to make sure you guys understand, when you see the word sum, sum is going to be the answer to an addition problem. So typically if they're talking about the sum and they're talking about another operation that's happening to the sum, that sum is going to go inside parentheses. Okay, if you are doing some kind of division to a sum, you have to find the sum first before you can divide it. So that means you would have to put the sum in parentheses to indicate that you are doing addition first. So whenever you see those keywords of sum, you should always think that parentheses are going to go around it, just in case there's another operation that's attending to it. Okay, and then another one that's a really specific one is the term more than. When you see the term more than, I want you to put stars right by it. So when we talk about more than, this is an order reversing term. And what I mean by that is if you see a problem that says 7 more than x, 7 more than x, then that means you are taking x and you're adding 7 to it. It is an order reversing term. Now, it might not seem like that big of a deal with addition because we do know, based off of our commutative property, 7 plus x and x plus 7 are the same. So that's not as big of a deal. But it is a big deal when you get to our subtraction terms. So just like we had parentheses around the word sum, we're going to put parentheses around the word difference. When we talk about taking a difference of something, that means that you're finding the answer to a subtraction problem first before you go on to any other thing. And then just like we have an order reversing term for addition, we also have an order reversing term for subtraction. That would be the less than. And that does matter. Okay? The way that you write your subtraction problem will matter. So if I were to say 5 minus 3 versus 3 minus 5, the answers are going to be different. 5 minus 3 gives you a positive 2. 3 minus 5 gives you a negative 2. Very different answers. So the order of subtraction does matter when it comes to the term less than. So it is also an order changing term or order reversing. So if we were to say 7 less than x, that means you have to write x minus 7. If you do not write it as x minus 7, it would be marked wrong. If you do not write x minus 7, it would be marked wrong. If you put 7 minus x, if you put 7 minus x, a different order, it would be marked wrong. If you don't write it in the correct order, you've got to be careful about that. Okay, then we have our product times, multiplied by, twice, and doubled, tripled. Those are all our multiplication terms. Again, we already know that twice and doubled means that we're multiplying by what? 2. Okay, tripled means we're multiplying by 3. Okay, then you have your division terms. You got quotient divided by half of, which means you're just dividing by 2. Third of means you're dividing by 3, and so on and so forth. All right, so based off of these terms that we've learned here, if we have the term 6 more than x, 6 more than x, first off, more than, what operation is more than, Nathan? Addition. So I'm going to go ahead and highlight that term in green. Okay, now looking back up here again, when I look at my statement more than, I'm remembering it is an order reversing term, which means that I'm going to take what was in the front and switch it and put it into the back. So what was in the back is going to switch and go to the front. So I am not going to write 6 plus x. I'm going to write x plus 6. When I see twice x, what operation is twice again? Multiplication. I'm going to highlight that word in my blue. Twice x means that I am multiplying, and what am I multiplying by? 2. So we have 2x. Okay, 2 less than triple a number. So we now have 2 operations here. What's one of the operations that I've got going on, Nathaniel? Subtraction, right? I have less than. Less than means it's a subtraction term. What else do I have? What other operation, Parker? Multiplication. I've got triple a number. So I'm doing 2 less than triple this number. So triple a number is going to have to come first, right? Multiplication always comes first. So we're going to take that triple a number and we're going to reverse it with the order of the 2. These 2 are going to reverse their order. So triple a number is going to be written first, 3x, and then we would write minus 2. Okay, 8 times the difference of x and 2. 8 times the difference of x and 2. What are my operations? Maritza? Multiplication. We've got the word times. What else? Subtraction. We've got difference. Now, key words here. Remember, we said difference was important because what do we have to do with difference? Jeremy? Well, we have to subtract, but what do we have to do? We have to... You have to get the answer first. So how do we indicate we're doing subtraction first? What are those called? Parentheses. Right up here. If it's a difference, you got to put it in parentheses when there's another operation occurring with it. So we're going to take x minus 2 inside of parentheses, and then we're going to put the multiplication of 8 on the outside. So 8 times x minus 2. All right, and then we've got some contextual problems. We don't always have just straightforward phrases for our expressions. Sometimes we're having to identify based off of a word problem that's been given to us. So go ahead and flip it on over to the next page. We are almost done for the day, and you will not have any homework tonight, nothing like that, no assignment. Okay? All right, so taking a look here. Kyla wants to buy a DVD player. She already has $25 saved. She plans to save $10 each week. We want to write that as an expression. So when we're writing expressions, we got to identify 3 very important things. The first thing that we want to always identify is what is our coefficient, if we even have a coefficient. So remember the following. When we're looking for coefficient words or values, we're looking for words like per, each, and every. Because remember we said per, each, and every, as long as it's in the problem and not in the question, it's considered a multiplication problem. And a coefficient is multiplied with your variable. So you're always looking for the term per, each, and every to represent where your coefficient value is going to be. Your variable is always going to be attached to your coefficient. So when I mean that it's attached, it's also going to go along with your per, each, and every. So you're not just looking for your number, but you're looking for what unknown value is going to be represented there as well. And then when we talk about a constant is typically a starting point or a one-time value. Something that you started with, or something that's only going to happen one time. Like often you'll see a fee. Terms like fees would be a good representation. So based off of what we know here, let's start with our coefficient. Where do we see the word per, each, or every? Sebastian? Okay, next is save $10, right? So here's our keyword each. That means the number attached to it is our coefficient. So here's our coefficient. It also means that the item next to it is our variable. So our variable is going to represent weeks. So our coefficient is going to be 10. Our variable is going to be weeks. So what variable letter do you think we should use if we're representing weeks? W. Okay, we want to use the term W. Now, it's fine if you wanted to go with X, but you would have to indicate that X represents weeks. Okay, and then our constant. Our constant is a starting value or starting point or a one-time value that's occurring, which happens to be right here, that she already has saved $25. She's starting with $25 in her pocket. She's going to continue to save $10 each week. Okay, so when we're writing this as an expression, we're going to say 10W plus 25. Okay, based off of that, I want you guys to go through, do problem 6 and 7 on your own. If you do that again, that's a silent lunch. Mr. Kirk does it, I think I will too. Okay, for problem number 6, $50 gift card is what they have. She's going to purchase different pencil cases, $6 per case, so we want to know how much will be remaining on her gift card afterwards. So you're subtracting away from $50, so 50 minus 6C. And then same thing with the cookies. 150 cookies is what they started with. And then she's going to sell the cookies 3 per pack. So how many cookies will be remaining after she sells them? 150 minus 3P. All right, have a really good weekend.